created by MindSticks Foundation Trust.
Hello learners, welcome to today's explainer. I am so glad you've joined me for this journey into applied microbiology. Today, we are talking about the invisible superheroes solving our massive real-world problems. We'll be covering 5 key areas: microbes as clean energy, tackling the garbage crisis, treating sewage safely, nature's pollution erasers, and finally, greener farming. Let's jump right in.
Let's start with Section 1, Microbes as Clean Energy, Powering the Future. Now, you already know that one of our biggest global worries is running out of fossil fuels, right? Coal and petroleum won't last forever. But the good news? Microscopic organisms actually offer us a brilliant renewable way out.
It is all about the biofuel cycle. It starts out quite simply. Plants absorb solar energy and carbon dioxide to create biomass. Once we harvest that crop residue, we extract cellulose, which gets converted into simple glucose sugars. And this is where the magic really happens. Through microbial fermentation, those sugars are completely transformed into liquid biofuel, fuel that can actually run our vehicles. And the best part? The carbon dioxide released just cycles right back into the atmosphere for plants to use again. It is a beautifully, fully renewable loop.
Now, what kind of clean fuels are we actually getting from these microbes? Well, there are 3 major ones. First, we get methane gas simply by letting microbes break down urban and agricultural waste without oxygen. Then there's ethanol. This is a lovely smokeless fuel created when yeast, specifically Saccharomyces, ferments molasses. And finally, the really exciting one, the fuel of the future, hydrogen gas. Certain bacteria actually release hydrogen during a process called photoreduction when water is broken down. It is a truly remarkable feat of nature.
Moving on to Section 2, Tackling the Garbage Crisis, Urban Waste Solutions. As our cities grow, our mountains of solid waste are growing right along with them. You have surely seen the garbage vans from your local Gram Panchayat or municipality collecting tons of daily waste. So, how do we safely dispose of all this? The answer is engineered modern landfilling. It's a very specific, step-by-step process. First, we dig massive pits in open spaces, far away from where people live. And this is absolutely crucial. We line the bottom with heavy plastic sheets. Why? To prevent toxic chemicals from leaching into our soil and groundwater. Once the degradable waste is dumped and tightly compressed, we add layers of soil, sawdust, and specific biochemicals. Then we pump in bioreactors and soil slurry to introduce the right microbes. We seal the pit, and in just a few days, those hardworking microbes turn that waste into top-quality compost.
When you understand how these sites are constructed, the genius is in the details. You've got that protective plastic lining at the very bottom, and nearby wells constantly checking the groundwater to make sure absolutely no toxins are escaping. Deep underground, as the microbes munch away at the garbage, they produce methane gas, which is safely collected through central vents. Once the compost is ready, we take it out and the whole site can be reused. It's incredibly efficient.
Let's look at Section 3, Treating Sewage Safely, From Toxins to Harmless Water. Now, a small village might just use a simple biogas plant for its domestic sewage, but in our heavily populated megacities, managing sewage requires massive, complex treatment plants that rely heavily on microbial action.
Inside these city treatment plants, microbes are doing some very heavy lifting. Their main job is to decompose the complex carbon compounds found in the sewage. But while they do that, they're also destroying dangerous pathogens, like the bacteria that cause cholera and typhoid. They literally turn a massive public health hazard into safe water. As they work, they naturally release methane and carbon dioxide. Now, what about those stubborn man-made chemicals? For that, we bring in special phenol-oxidizing bacteria to neutralize those tough xenobiotic chemicals. In the end, the sludge that settles at the bottom gets scooped up and makes for an absolutely excellent fertilizer.
Okay, Section 4, Nature's Pollution Erasers, Clean Technology. We humans have advanced incredibly fast technologically, but sadly, our environmental pollution has kept the exact same pace. However, let us take a moment to appreciate something wonderful. Certain microbes have the miraculous ability to literally eat and decompose our most stubborn, man-made messes.
You've probably read those tragic news stories about fatal petroleum oil spills in the ocean, leaving dead fish in their wake. Trying to clean that up mechanically is nearly impossible. But nature has a built-in cleanup crew. They are called hydrocarbonoclastic bacteria, or HCB for short, specifically species like Pseudomonas and Alcanovorax borcamensis. When we deploy these into the ocean, they destroy pyridines and decompose the hydrocarbons. They react the carbon with oxygen, turning that fatal oil spill into simple, harmless carbon dioxide and water.
And their superpowers do not stop at oil spills. Some microbes can pull sulfur straight out of our fuels. Even more amazing, bacteria like Geobacter can tackle radioactive metals. They take uranium salts leaching from atomic plants and convert them into safe, insoluble compounds so they cannot contaminate our groundwater. What about our huge plastic problem? Get this. Species like Vibrio and Ideonella sakiensis can actually digest PET plastic bottles, and Actinomycetes can even break down tough garbage rubber. They are literally nature's ultimate erasers. Finally, let's look at Section 5, Greener Farming with Microbes, Natural Agriculture. For decades, we have relied heavily on chemical fertilizers and pesticides, but this has caused severe soil pollution, harming plants, animals, and of course, human beings. The safer, smarter path forward is organic farming. To make this greener farming a reality, we use something called microbial inoculants. These are helpful microbes that we produce through fermentation. Before a farmer sows their crops, they simply spray these inoculants onto the seeds or release them directly into the plants. They act like natural, invisible growth boosters. They supply vital nutrients and improve crop quality without any toxic side effects. In fact, by using solutions containing microbes like Azotobacter, farmers can completely replace those harsh chemical fertilizers.
But what about the hungry pests that want to eat those crops? Instead of spraying toxic chemicals all over our food, we can use bioinsecticides. We can actually integrate specific bacterial and fungal toxins right into the plants. Now, these toxins are fatal to the target pests and pathogens, but, and here's the best part, they're so highly specific to insects that they cause absolutely zero harm to the plants themselves or to the humans who eventually eat them. A great example of this is spinosad, a wonderful biopesticide created as a byproduct of fermentation.
And that brings us to the end. As a quick reminder, I highly encourage you to go through the textbook exercises for this chapter on applied microbiology to really lock in what you've learned. You've all done wonderfully following along with this complex biological journey today. But before we sign off, I want to leave you with a bit of homework, a thought-provoking question. We learned today that certain miracle microbes can actually decompose plastic. So, why is it still absolutely necessary for us to ban the use of plastic bags? I want you to really think deeply about the massive scale of our daily plastic use compared to the natural speed at which these microbes can actually work. Biotechnology holds incredible promise for our environment for sure, but our daily human habits have to change too. Keep studying, keep questioning, and I will see you in the next explainer.